So number 2 is very similar to number 1, but they're only asking the question of how far short of the target does it strike the ground. So Mr. Namath with his arrow, he's 50 meters away. Looks like we're not given, yeah we are, right here, 1.5 meters above ground, and initial velocity. So first thing I'm going to do is draw our diagram. So here I'm just going to write, here's the ground, starting at 1.5 meters above ground. He is shooting an arrow at 75 meters per second. So that's awesome drawing. All right. Again, this is why I'm in math and not art, but nonetheless, we've got 50 meters down below, or 15. There we go. Try 50. Again, just general dimensioning. 1.5 meters this way. And it is horizontal, so it's just a straight out. I'm just going to draw something like that. I'm going to show 75 meters per second. So they're basically telling you it is going to land short. The question is how much short. So our horizontal velocity is, we start with 75. I'm not going to label it that way. I'm just going to say 75t, right? So our x direction vectors are the initial velocity, or all vector forces in the horizontal, times t. In this case, all we have is the whole 75 meters per second is horizontal, so 75t. In the y direction, okay, that was x1. y1, we don't have any vertical component to the speed of the arrow. It's all horizontal. So we do have our y-intercept, or our starting height, of 1.5. And from that we have to keep reducing due to gravity. So we subtract 4.9 t squared. Alright, so we're going to plug in x1 is 75t and 1.5 minus 4.9 t squared. So let's see, we've got our component, we've got our x and y vectors, we've got our graph. Next thing is graphing our equations. So we had 75t and we had 1.5 minus 4.9 t squared. Alright, now the big thing here is going to be time again. So 0 to 5 should be safe. We're going to iterate at 0.1 just so that it takes less time from the calculator standpoint. Our target is 50 meters away. So our x max is 50. And our y max, well, we start at 1.5 meters and it goes horizontally until it hits the ground. So here's our graph. So right here at the end of our graph, that's going to represent where the target sits. The problem is we can see that our arrow takes a path that is less than 50. So what we want to do is find out where it hit the ground and then subtract that from 50 and find the difference between those, and you find how far short of the target we were. So at 0.5 seconds we were above, 0.6 seconds we were below. So the next thing we got to do is reiterate at 0.01 step. I'm going to regraph that. And once it's done, we'll trace. And I think that was 0.5 seconds. Yep. So we're going to keep going, keep going. And this step here is just getting a more precise answer to the question. So somewhere between 0.55 and 0.56. I'm going to say 41.25, between 41.25 and 42. Let's just go with 42 to make our numbers easier. So we're going to go back to the problem. We know that we traveled 42, so this distance here was 42. Target was 50. And let's see, difference is 8 feet. So, have we answered the question? Yes. I believe there was a box for it. Distance toward the target to the nearest meter, so I should probably label that correctly. How about not feet, but meters. We drew our diagram, we gave our vectors, we showed our work, and we have our answer with correct units now. So that is number 2. Again, it's x1, y1, plug it in, and then find the data you're looking for.